So this is our lecture on quasi-experimental designs and program evaluation. And so what we've talked about thus far in the semester is what we can do in a lab where we have kind of a high amount of control. But a lot of the research questions we have are really about applying this research to the real world. So applied research is really about testing the external validity of lab findings. Can we generalize what we found in the lab to improve the conditions in which people actually live and work? So we'll talk about two general strategies for this. One is quasi-experiments, where we try to approximate the conditions of a highly controlled lab experiment, and then another is program evaluation, in which we use applied research to really learn if real-world treatments actually work. Okay, so true experiments are what we've been talking about thus far, which really are kind of lab experiments where we have a lot of control. And so this chart does a nice job kind of comparing and contrasting true experiments to quasi-experiments. So true experiments really emphasize internal validity. We're manipulating the independent variable with a high degree of control. We're randomly assigning participants to groups so that we can unambiguously say that the independent variable had an effect on the dependent variable. In contrast, quasi-experiments really focus on external or real-world validity. And so we want to be able to apply what we found. Does it actually work in the real world? Another big difference is that in true experiments, we assign participants to be in experimental or control groups, either random assignment or matching, and this is a really important part of getting that internal validity. In contrast, in quasi-experiments, we use existing or non-equivalent groups. So we use groups that are already in place and are not randomly assigning people. And so there's a lot less control that we can get in these quasi-experiments. So that leads to the final point where in true experiments, we really focus on controlling study procedures to make sure that everything between our groups is exactly the same, where in quasi-experiments, we often have a lot less control. So we might not be able to directly manipulate the independent variable, and so we have to try to figure out what conclusions we can make based on what we can control. Okay, so the big issue we're dealing with here is internal validity, which is the degree to which differences between groups on the dependent variable can be attributed unambiguously to the independent variable. We want to be sure that any change in the dependent variable comes from the independent variable and not something else that we haven't controlled. This is easier to do in true experiments because we've controlled everything. So we're going to talk first about kind of a series of potential threats to internal validity. So again, internal validity is being certain that the dependent variable and nothing else created change. The independent variable and nothing else created change in the dependent variable. So some of the threats we have to worry about. History. So history is when an event occurs kind of at the same time as a treatment and changes the participant's behavior. So maybe something outside of our study can change the behavior. Regression is when individuals sometimes perform very well or very poorly just by chance, and so the next time they get closer to the overall group average. Maturation, which is participants just naturally get better or worse over time. Selection has to do with differences between the participants that we put in our treatment or control groups at the start of the study. So those differences have nothing to do with what we actually did in the study. Testing has to do with kind of the fact that just taking a test might change how we perform on it in the future. Subject attrition is that some participants might drop out of our study and that could influence our findings. Instrumentation is just the instruments or the tools or the measures that we use in our study could change over time. And then additive effects where these might work in combination. Okay, so when we talk about quasi-experiments, quasi means resembling experiments. We use these as alternatives when true experiments are not possible. So normally we have some kind of intervention or treatment and a comparison group, but we don't have a lot of control over who is in these groups. So in a true experiment, we really focus on randomization, so randomly putting people in groups. In a quasi experiment, we often use pre-existing groups. So we might do something with children in a school and have, we can't randomly assign kids to class because they're already in class. So we might do one intervention with one class and a different intervention with another class, but we don't have that true random assignment. And the justification is basically that some knowledge is better than none, right? It's better to know how a treatment works in a real classroom setting than to not know at all, but we have to be aware that we didn't randomly assign kids to these treatments, so there may be other factors at play. Okay, so we're going to talk about a couple of different designs that can help us create quasi-experimental studies. So this is often the first step of a bad experiment, of a quasi-experiment. Sometimes you can think of this as kind of a bad experiment or pre-experimental design. So a one-group pre-test, post-test design is where you have one intact group that is selected to receive a treatment. You're going to see this notation here where O and the number represents an observation, and a lot of these things we'll observe more than once, and X is where a treatment is implemented. So in a one group pre-test, post-test design, we have one group, let's say a class. We do an observation now, so we assess their reading levels at the beginning of the study. We do some kind of reading intervention, which is the treatment or the X, and then we do a post-test observation, so we have them take the same reading tests. Okay, so this is, obviously there's a lot of issues. We have no control group, but we've done something. And so we haven't really controlled any of the threats to internal validity. Any change that we see between the pre-test and the post-test could be due to treatment or history or maturation or testing. There's a number of things that could be going on. Another strategy we might use is non-equivalent control group design. So here we select a group that's similar to the treatment group to use as kind of a comparison or control group. And so for both of these groups, we get pre-test and post-test measures, but we're not randomly assigning people. So this is, if we have this reading intervention, one third grade class gets the intervention, another third grade class doesn't get the intervention. So this is what it would look like. So that dotted line, above the dotted line is the treatment group. They take the pre-test, they get the intervention, they take the post-test, and then below the dotted line is our second non-equivalent control group. They take the pre-test, they don't get the intervention, and then they take the post-test. So with the control group, we can rule out some of the threats to internal validity. But there's a number of issues that we can't rule out. So we can't rule out the effects of kind of pre-existing differences or issues with selection, but this gets us at a better sense of if there was something big that happened, it would happen to both of our groups. So we could have a better sense. So if, for example, school was shut down for several weeks, that would be true for both of the groups. And so we could tell whether the treatment made a difference above and beyond that. Next is a simple interrupted time series designs. So here you're going to observe the dependent variable multiple times before and after the treatment is introduced. Now we only have one group, but because we're measuring them many, many times, what we can look for is discontinuity in evidence. So you can see this laid out where you've got 1, 2, 3, 4 observations, and then the treatment, and then 4 more observations. So this is what it might look like. So we're taking a series of observations. So this is looking at suspensions for speeding. This is looking at archival data, and they looked at the number of speeding tickets before and after a government crackdown on speeding. And what you can see is at the treatment, there's this clear discontinuity where you have fewer tickets before and then more tickets after. And so this is really beneficial because we can rule out some of the threats to internal validity, like maturation and testing and regression, because we are having people take the same or making the same observation multiple times, both before and after the treatment. Another similar design that we might use is the time series with non-equivalent control group design. So this is the same thing, but we've added a comparison group that gets measured at the same time with no intervention. So again, this dashed line indicates that above the dashed line is our treatment group, where we've got multiple observations, treatment, and then multiple observations. Below the dashed line is our control group. It's not randomly assigned, but we're taking multiple observations from that group as well. So those are a couple of different quasi-experimental designs that can help us apply some of the stuff we may have learned in the lab to a more real-world setting, even if we can't randomly assign groups. Okay, so next is program evaluation. So this is really important. It's one of the most effective forms of applied research. And the goal is, all of these human services and other organizations have these programs that are designed to help people, but they need to know if they work. So they need to be able to decide what services to provide, who to provide the services to, so who's going to benefit the most, and how to provide these services effectively and efficiently. So this is growing in a number of fields, but if we think about healthcare, how can doctors treat patients? Which patients should they target? How can they do it efficiently, cost efficiently, things like that. So there's 4 key aspects to program evaluation. So one thing the programs need to know is the need. So is an agency or organization meeting the needs of the people it serves? When needs are unmet, is the program something that people actually need that they can't get anywhere else? And so surveys are often a really effective tool for assessing needs. There's also questions about process. So is a program implemented the way it was planned? How is it being carried out? Often observational measures are really useful for this. Next is outcome. So is a program meeting its goals? So this is really where experimental or quasi-experimental designs can be beneficial, where we can compare a group that gets the program to a group that doesn't get the program. Archival records can also be really useful for looking at the effectiveness of outcomes. And then finally, efficiency. You can kind of compare two alternatives, look at the cost, look at how quickly these interventions are implemented. And so we can also use experimental or quasi-experimental designs or archival records to look at this. So these are some kind of more applied aspects of some of the research methods that we've been talking about thus far this semester.